In part C, we now try to understand key scientific concepts. Okay, what do I mean by that? I'll give you a first example. Let's see. All right. What are budgets? All right. So definition. What do we mean by a budget? A budget is simply the inventory of all contributions to a property. Okay, the total is A plus B plus C plus D. Okay. You can also express the contributions of these individual things, A, B, C, D, as relative percentages. What's the relative percentage? You just have to divide A by the total times 100. You get the percentage. And I give you one example. Here's the water volume budget just above my head. Let's go with the mouse. Water budget on Earth. Okay, so where do you find water? How much water is in the oceans? And you can express it in units of cubic kilometers times 1,000. That's what these numbers are. How much water is in groundwater? How much is in ice? How much is in lakes? How much is in soil moisture? How much is in the atmosphere? How much is in rivers? You can write down all the numbers, and then you can add up all the contributions, work out the total, and work out the percentage. Okay? And in the oceans you have 94.12%, groundwater has 4%, ice has 1.67, and down, and atmosphere has 0.001%. Okay? I highlighted ice and the atmosphere because they play an extremely important part in the climate system. Ice because of the albedo, atmosphere because of the greenhouse effect. That's what we call a budget. Okay? Examples: water volume budget, precipitation minus evaporation is a budget. We're talking about energy budgets, heat flux budgets, carbon budgets, nutrient budgets. It's all, you can look at many different type of budgets. Okay, so I want you to understand what I mean by budget. Second is, what are cycles? There are two different definitions. Okay. Definition number one. A cycle is defined as a series of events that are regularly repeated in the same order. Something that repeats in terms of time. Okay? Day-night, daylight cycle. Seasonal cycles of temperature and rainfall. Tidal cycles of sea level variation. Repeat, something that repeats. Okay. The other definition is something of a cycle which is not repeats, but which happens all the time, but which is, I just read the definition to you first. A cycle is a description of all transfers of a property between different spheres of the climate system. It's the transfer of, if you look at the water cycle. Okay, it's above here in my head, a sketch of the water cycle. It's the process of transferring water from the ocean, from land surface, from lakes, into the atmosphere, and then they return through rainfall, and then through streams ending back in the ocean. It's that cyclic connection between the transfer of a property. And there are different examples: water cycle, carbon cycle, nutrient cycle. Okay? I want you to understand what we mean by cycle. Okay? And both different types of cycles. That's very important for you, that you have a good understanding of not how it works, but just the concept of what do we mean by a cycle. Okay, next one. What are fluxes? Okay. A flux of a property tells you how much of the property is transferred per time unit across an interface from one to another compartment of the system. So you have an interface, say the sea surface. Okay? Have a look at the sea surface as your interface, and then you can have a flux of a property across it. Okay, so you grab 1 square meter of surface, and then a flux means now how much per time unit, how much per second. You can have a particle flux, numbers of particles crossing a surface per second. Okay, and we always use a unit surface of 1 square meter. Okay, you can have a heat flux. The unit is watts per square meter, which is joules of energy per square meter per second. Okay, you have precipitation and evaporation. Unit is millimeters of liquid water per day. In this example, we don't say per square meter. We don't explicitly say per square meter. We just say millimeters per day, but indeed each square meter receives then the same amount of rainfall. Okay? So precipitation and evaporation are also fluxes. And if you have a flux, means that there's always something coming in. You know, if you have a flux, people entering a football stadium, you get more and more people into a stadium. So the crowd is filling up. And that's really important to understand in the context of fluxes. It's a change per unit time. Okay? That's what we call a flux. Other example of interfaces is indeed you have the soil surface, the land surface. Okay, that's an interface. Okay. All right. You can also look at cloud surface as interfaces also. Okay, so now the last bit is what are anomalies? And anomalies are tricky, are really tricky. An anomaly is a difference of a value of a property compared with an average or a reference value. Okay? Anomalies are frequently used in the climate sciences. Okay, temperature anomalies are often, that's not the hard bit, it's often referred to a reference value. So, for example, if it was 20 degrees yesterday and today is 21 degrees, you use a reference of 20 degrees Celsius, then today the temperature anomaly is 1 degree. Hooray. Okay? But referring to anomalies can be very confusing. Like, I give you a few examples. A positive temperature anomaly does not imply a positive temperature. For example, you can be in an area which is minus 20 degrees normally, and now temperature increased by 1 degree to minus 19 degrees Celsius. So you have a positive temperature anomaly, but the temperature is still negative. A negative heat flux anomaly does not imply a negative heat flux. An easterly wind anomaly does not imply an easterly wind. So it can get very confusing. If you throw the word anomaly at people, you can absolutely mess up everything. And as one example, and not to mess up things, but just as one example, I want to show you easterly wind vectors and anomalies. So just a little bit of scientific content in here. So easterly wind, we're referring to wind that comes from the east. And you can illustrate easterly wind by vectors which has a direction and a certain magnitude. The length refers to the magnitude. So you think about one wind event or a situation where you have a wind speed of minus 5.2 meters per second. Okay, so then the next time you have minus 5 meters per second. Minus is really important here, it comes from the east. Then you have minus 4.6 meters, and then minus 5 and minus 5.2 meters, okay? You take the average, You just know, you know how to calculate an average. Just the sum divided by 5, you get minus 5 meters per second. So now we talk about anomalies. And the reference here is the average. Okay, it's always important if you talk about anomalies to specify what is the reference. Okay, and you can see the first event here is smaller. Okay, so you have lower, it's minus 5.2. The second one is the same, no change. And here, this in the middle, the event is actually, you have a positive anomaly. It's 0.4 meters per second, because it's, you know, it's not minus 5, it's only minus 4.6. So it's a positive anomaly. All right, and here you have a negative anomaly. So it's always, whenever somebody says anomaly to you, you should always stop and think about what is the reference. It's difficult for the brain to work out this. Okay. All right, a summary of this lecture. No, it's not a summary. It's actually study questions. Oh, hooray. So describe key features of the lithosphere, the atmosphere, the ocean, and the cryosphere of relevance to the climate system. Okay, what is thermal radiation? How can you distinguish the temperature of surfaces? Okay, what is a flux of a property? Give examples. Okay, how is Darwin's evolution theory related to the drift of continents? So what is the link between these two theories? Okay. Describe key features associated with the phase change of water. All right. Thanks for watching. I hope that you enjoyed that. If you have any questions or suggestions, feel free to contact me. All right. See you.